Hi everyone and welcome to this new video. In this video I start a new series and this series will be about Linux privilege escalation. So this is gonna be the first video of the series, and in this introductory video we will introduce the idea of the Linux shell. So we will discuss a lot of different concepts and you can find them here. We will go into a lot of details here. Now, regarding with this series, with respect to the other videos that I'm planning to make, for now, this is my idea. Of course, it could change with time as I go further into the series, but the idea essentially is that I've already covered the path hijacking video, so that is already done. And then I want to talk about file permission, sudo exploitation, wildcard expansion exploitation, and then finally some enumeration, general system enumeration, and cron job enumeration specifically. So this is my idea for the series. Once again, my target is, for example, an OSCP certificate. So this means that if you understand all the concepts that I cover in this series, and you do of course a lot of practice, because theory is important to have, but then you need to do a lot of practice and just laboratories. If you know all of this and you are used to doing these techniques, then you will be able to obtain an OSCP certification, or anyways, you will have the required knowledge with respect to the Linux area. So my target for this series, for the web exploitation series, which I've just finished, and also for the Linux privilege escalation and the Windows privilege escalation that will come, is OSCP. I'm trying to build a foundational OSCP knowledge. Once I've done that with all the series, we can go further. We can go more in depth, more difficult topics. So now that I've introduced everything, we can actually go into the content of the video. So the first thing that I want to do is I want to showcase this simple Docker file. This creates essentially a container that has SSH login on. And I'm doing this to create a playground when we can actually play with the shell in order to understand how it works. So this is the Docker file. It creates this sort of container, this environment where we can play with the shell. To actually build it, we need Docker installed in our system, and then we can execute these commands. So Docker build to build it, Docker run to run it, and then we can either do Docker execute to obtain a shell, or we can actually log in with SSH. And the credentials here are SSH user and password. Now in my system, the one I'm using, I've already run it, so we can just log in with SSH. And this is essentially where I wanted to start this video. So consider this SSH command. This is a command that we can execute through a command shell, through a Linux shell. Now this command is made of various parts, and when we want to understand how the shell functions and how we can use it, we need to understand every part of this command. Now, first of all, why should we use the command line? Why should we use the CLI, which stands for Command Line Interface? So this is a way in which we can speak with the computer. It is an interface, but instead of being a graphical interface, a so-called GUI, which stands for Graphical User Interface, so graphical user, this time is a command line interface. It means that to interface, to interact with the computer, we use commands. And commands are a string of text. They are just a sequence of specific characters that have a specific structure, and we will need to analyze this structure. But the idea is that instead of having buttons in the screen where we can click on them, we have strings, we have commands that we can execute. Now, why should one learn the CLI instead of sticking with a GUI? Well, the idea is that even though GUIs initially can be helpful, especially when we are at the start of our journey into learning cybersecurity or computer science, the thing is that the GUI long-term has certain downsides that we only see when we become expert in cybersecurity or computer science. Specifically, GUI are extremely complex to handle, and typically they are easy to use with the mouse, with the keyboard, but they always require some kind of manual interaction, some kind of user interaction, like a user sitting in the computer clicking on stuff. That's like manual effort every time. The power of the command line is that once we learn how to use it, we can automate stuff, we can script, we can write programs that do things automatically, that perform like commands and operation on the operating system without any user interaction, based only on the output they get from other commands, on the state of the computers, and so on and so forth. So the idea is that even though at first it may seem that CLI commands, that command line interface, is just boring and hard to learn, in the long term it will actually save you lots and lots of hours, and you will be glad to have learned it. I mean, this is the idea. Like when I started to learn computer science, I was like, wait a second, this command line is very, very hard. I need to remember all these commands, I need to write them out, etc., etc. But then I actually learn the power of the command line, the fact that I can automate stuff, that I can write script, and it is a very efficient way to interact with the computer, to talk to the computer and obtain information about its state. Because the idea is that at any time the computer has a certain state, and if we want to operate properly on the computer, if we want to use it, if we want to use it with all of its resources, we need to understand how to extract the state, how to understand the state, and how to execute specific commands to move the state in specific directions. So that's the idea. For example, in this SSH command, what we see is that the first part is the name of the command. So this defines the program we want to use, and every command line program has a name. Actually, even every GUI program has a name, because ultimately the command line is the first way we interact with the computer. First we interact with the command line, and then we tell the computer to spawn graphical interfaces. So it means that GUI are built on top of CLIs, on top of command line interfaces. So that's the idea. So the first part is the name. Then every command has different options that sort of modify the behavior of the program. This is because, of course, programs are really, really complex and they have to interact with the user. So we have to tell the program how to behave exactly, which means that each program will have a different set of options, and these are specified in different ways. Now, this is where the complexity of command line sadly arises. This is never truly easy, and the best way to handle this is to read documentation and write your own documentation with respect to how the options are written, essentially. So for example, consider this case. Now, SSH is used to create a secure communication channel between two endpoints. So essentially is that we have two TCP ports, one here and one here, and we want to create a secure channel on top of this, which means that the data that is transferred between these two TCP endpoints must be encrypted and must be protected with respect to integrity also. So a lot of cryptographic protections. Now, to do this, what we say is, essentially we have to specify the machine to which we want to connect. And here we do it with this syntax. So this is the username we want to log in into the machine, and this is the IP address of the server that is listening, because SSH has a client-server architecture, and in particular, this command SSH implements the SSH client. So this is the open source SSH client, so it's implemented in this command. And so we say, look, I want to connect with SSH to the server running at 127.0.0.1 with username SSH user. Now notice that since we are connecting with TCP, it is assumed that we need to know the port, the TCP port where the SSH server is listening to. In this case, we are not specifying the port because implicitly we are using the default port 22, which is assigned to SSH. Now this is like an implicit stuff, we don't put it into the command line because the program already knows. So every time the program already knows the data, we don't need to explicitly tell the program. However, for example, let's say that we had a different SSH server listening on port 77. Now in this case, I will need to tell somehow, with using certain flags, how to connect to that port. And the fact that it was not port 22 that I was interested in, but rather port 77. So this is the first thing. But notice that after the SSH and before the SSH user at, which stands for username IP address, here we have another thing. Now this is called an option, and essentially it modifies the behavior of SSH. In particular, I'm telling SSH to do a certain operation. Now every time I connect with SSH here, if I remove this, what it does is it tries to understand the authenticity of the machine I'm connecting to, of the host I'm connecting to, by analyzing its public key, the fingerprint of its public key. And it asks me, do you want to save this for future connections, so that future times, if you connect to the same IP and port, you will get the same fingerprint. Essentially, a check will be made to make sure that the fingerprint has not changed, because this could mean that the machine has been compromised, so we don't want that. So it asks us if we want to save this fingerprint or not. And typically, if we say yes, I want to save it, it saves it into a system file that is actually not system, but it's like based on a specific user. So it saves this fingerprint on a specific file, and I don't want to do that. So essentially here what I have to do is I just have to do this to say, look, okay, we go into terminal, and you have to say, look, I don't want you to save this fingerprint for long term. I just want you to connect. So it says I can say yes now, and when it's gonna try to save the file, to save the fingerprint within the file, it will actually just discard it. And now it asks me for the password. The password is found in the Docker file, so it's this one. It's called password. So I can just copy, paste it, and now I am inside. I am inside the Docker. I've successfully run the SSH command, and I can do various commands that we will talk about now. Now, in order to use this command, we had to answer the following questions. So first of all is, what kind of program do I need to access that functionality? In this case, it was connecting with SSH. So every time we have to operate with the computer, we have to do different actions, and different actions are done with different programs. So one of the things that you need to master if you want to use the Linux shell is understand which program does what, to make sure that every time you have to do a specific action, then you already know the program that you need to use. So this is the first question, is that what program do I need to use? In this case, we had to connect with SSH, so the program we needed to use is called SSH. Now, to use SSH, of course, we have to connect to a specific server. So the next question is, okay, what kind of IP address is the server I'm trying to connect as? So what is the IP address I'm trying to connect to? And then what is the username? And then what is the password? And then if I want to make the program behave in a certain way, for example, by not saving the public key of the server, then I need to know, okay, but what kind of option allows me to modify the default behavior of the program to avoid saving the public key option? So this is all the complexity of the Linux shell. And in this video, I will start with some basic concept to help you get started playing with the shell. So a useful starting point is to understand the difference between concept of like terminal, TTY and shell. In this case, it's like, consider we have the terminal, TTY and bash. So here we have the user. Now the user typically interacts with a terminal. For example, Xterm. So Xterm is a terminal, and I can open Xterm right here. So for example, in this case, this thing that you see here, it is called Xterm. So this is a graphical user program, a GUI program that actually allows us to communicate with the shell. So even though, we have to sort of like separate the graphical part of the terminal with the shell itself. Now, why do we have to make this distinction? Because the idea is that there can be many different types of terminal that use the same shell. So consider what is happening here, for example. Here I have open Xterm here, but I also have this other shell down here. This is because I have two terminals. This one is Xterm, and this one is called instead vterm, and vterm is handled by Emacs, the programs that I use. So every time you see the terminal like down below, it is called vterm, which is run and handled by Emacs. While, for example, Xterm is a different terminal implementation. So the concept of a terminal has to do with the like graphical user environment. So right now I'm running X11, which is the server that handles all the graphics and stuff. So the idea is that I have different terminals because the terminal implements the graphics to interact with the shell. So it's like it is the thing I interact initially. Now continuing, both terminal, so in this case xterm and vterm underlined here, so the one on top white and the one down here, vterm, so both of these terminal are actually running the same shell, which is called bash. So bash is a command line interpreter. So there's this word, interpreter. And the idea is that we give to bash a series of commands through text. Bash understands the text, understands the commands, and executes them on the operating system. So that's the key difference between the terminal and bash. Bash is the interpreter of commands that executes them, and the terminal is just the way we interact with it graphically. Now, between the terminal and bash, there's actually a third component, which is called a TTY, and without going into the details of this thing, you can actually think of the TTY as a sort of like channel where data is exchanged in two directions. So from the terminal to bash, and vice versa from bash to the terminal. So it is like this communication channel that the terminal and shell use to exchange information. And on this regard, I found a cool article that exposes the differences between these components. So you can go and read it. It's here. It's this article. So I just suggest, if you're interested, just read this article. It's really, really useful, essentially. So that's the diagram where I took it. So if you are more experienced and you want to see more details, you can read that. For now, we will stick with the basic and we'll just think, okay, we have the terminal, which is the graphical thing we interact with. Then we have the shell, which is the component that interacts with the actual operating system. So it's the last component. And between the terminal and the shell, we have the TTY, which is this communication channel. Now notice that there are many different types of shell. That is, there are many different types of command line interpreters. For example, another type of command line interpreter is called SH, which is simpler than bash, if I remember well. So like we can do /bin/sh, notice here. Now here in this xterm, here I open SH. So I'm using the same terminal, is still xterm, but now the underlying shell, the final shell, the program that allows me to interact with the operating system, it's no longer bash, but rather it's SH. So this is why I wanted to mention the difference between the shell and the terminal. The shell is the interpreter you use, and for example SH is a shell, you have the bash shell, there is also the fish shell, so there are many different types of shells. And also there is the terminal, which is the graphical program you use to interact with the shell. Typically, if you want to configure your system, you have to choose which shell you use and which terminal you use. When it comes to the TTY, that is more technical, and for beginners, I think it's not really that important. So it's just remember that it's a communication channel that sits in the middle of these two components. Okay, now that we covered this, we can actually kill this terminal because we don't need that. We can just work with this and we can continue, and we can start to talk about basic information. So the idea is that every time we are using a shell, as I said, we have to use programs to extract information out of our system. And this is really the first step, is to extract information, to understand, wait a second, what is happening? What can I do? Who am I? What are the files? What are the resources in this operating system, in this system? So in this chapter, we will talk about extracting basic information. So the first basic information we can extract has to do with the username. Now this is because modern operating systems have different users. So you will have many users in your system. And this is done to make sure that the programs, the resources are divided between the users. So you have an administrator, you have a normal user, you have a service user. So you have different types of users depending on what you need to do with the system. Just imagine that you have an operating system that is accessed by many different people. So each one of them will have their own user with their own permissions. So if you want this kind of permissionful system where each one is its own permission, you need to have the concept of users, and modern operating system have that. So the first command you can type is, okay, who am I? This command gives you your current username, so the user you are interacting with the shell. This is because every time you are interacting with a shell, you have a username. So you are given a username and you can extract it with the whoami command. In this case, the whoami tells us SSH user. And notice that we can also see it in the prompt. So this is the prompt is the thing that gets printed for every new line. So every new line, here I start to type, right? But there's something before I start to type. That is the prompt which contains basic information. Now, sometimes the shell do not have a prompt. For example, if I use SSH, just notice with SSH, with this other kind of shell, I do not have a prompt. So notice that SSH is a more primal kind of shell. It's a more primitive kind of shell. If I do exit, I get back to bash, and here I do have a prompt. So this shell has a prompt. So that's the first thing. Another command that you can use to extract information regarding who you are is the id command. Now the id is a little bit more complex because it actually gives you information about your user ID, UID, which is 999, and this is the username. Then it gives information about the group ID, so this GID, which is 0, it's root, and then it tells you which groups you belong to. So in Linux operating system, root is also the administrator. So the administrator is known as root. So it means that I belong to the group that is owned by root. So to the root group, essentially. So this is the first piece of information. It's like, who are we? What can we do in this system? Well, the first thing that we need to understand is who we are. In this case, we can use whoami or id. Now the next command is the hostname command. This tells you the name of your host. So this is like the name of the server you are interacting with respect to the network. So this is like the name. In this case, notice that this name is the same thing that we see in the prompt. This is because the host name of this Docker is this string of 718878. So a bunch of characters. This is the host name. So this means that in the prompt, what you see is the username extracted with the whoami and the hostname extracted with the hostname command. So getting comfortable with the shell is all about learning what kind of commands give you what kind of information, and to understand in a given context, you are like, okay, I need this piece of information. What is the right command? So do not try to memorize all commands because that thing will not work. Rather, try to understand what you can do with a shell, what are the resources you can access, how you can access them, and then once you have an action, once you can conceptualize an action, you can say, okay, I need to know what user I am right now. Then you can go and search for the right command. You can maybe write it in a piece of paper, in a note, in a file txt, something like that. And this is how you get comfortable with the shell. Do not go and try to memorize all commands because that doesn't work. It takes months, of course, to learn this kind of stuff. It's not immediate, but the focus is that try to think conceptually on the things you can do with the shell, on the information you can extract and interact with the shell. So the first two basic information is username and hostname. A third basic piece of information is the working directory. So this is extracted with this command, which is called pwd, which stands for print working directory. So if we execute this command, we get this result. So we get this result, which is like /home/ssh user. Now this thing actually is representing a path in a file system. So we have a path. Now a path is like, intuitively, a path is like a street we can go, somewhere we can go, right? Well, a path in the context of a digital file system is essentially the same thing as a physical path, sort of. It tells us where we are in this file system. And you can think of the file system as like a tree of resources. We have a starting point, which is called the root of the file system. And in Linux, the starting point is symbolized by this slash. And then starting from the root, you have a bunch of different directories or files. And for each directory, then you have other resources. So you have this sort of tree of resources. And every time you jump into a node and you go down, you are adding stuff to your path. So for example, in this case, how can we read this /home/SSH user? The idea is that we start from the root, so this is /, then we go into the home node, and then we go into the SSH user node. So here we are right now. Here, this is our path. So the path is like this series of nodes in the file system. And with the working directory command, we understand the working directory. Now, the idea of a working directory is that every program that executes in the operating system has a series of information, such as the username who started that program, like that program is running as the user Leo or as the user SSH user, stuff like that. And then it has a working directory. So every program has the concept of a working directory, which is sort of like the base place where all the resources can be accessed to within that program. So you can imagine it as a sort of like the point of view of the program within the entire file system. So the working directory, you can get access to the working directory of the shell with the pwd command, which stands for print working directory. This is extremely useful because, for example, while the username and the hostname were pieces of information that we could extract just looking at the prompt here, we could know, okay, this is the username and this is the hostname. When it comes to the working directory, sometimes the prompt does not tell us. We can customize it, we can customize it to make sure it tells us, but sometimes it doesn't tell us, which means that we could have a different working directory, and so we can ask, like, every time we work. So for example, now I'm gonna do an operation, I will explain later, and so for example, I go here, so now I do print working directory, and it says /. Now I go into TMP, okay, now it actually tells us, so print working directory /tmp. So in this case, when we went into here, it did not tell us explicitly /home/SSH user, because actually here there is this character which is called a tilde. So this is called a tilde, and in Linux operating system, a tilde is sort of like an alias for the home directory of the user. So since I am currently in /home/SSH user, and I am the SSH user, it's sort of like I am in my home. I am in my home folder, so it just prints the tilde. So this is sort of like an alias. So we have username, hostname, working directory. Two other pieces of information are the environment and the which, like the which command, which is extremely useful. Now when it comes to the environment, so we go here to our shell, essentially it's that every time we have a program, we also have so-called environmental variables. So these are like a programming language variables. The difference is that they do not belong to a specific like language, they belong to the program itself. So it's sort of like they are variables that the program can use to interact with other resources, with the operating system and stuff like that. So once again, they are variables that control the program, in this case the shell, but also other programs have environmental variables. Now to get access to the list of environmental variables, you can just write env. Now notice that this kind of environmental variables have the same syntax, so it's like the name of the variable, then there is an equal, and then there is the value of the variable. So in this case we have pwd/home/SSH user, we have shell, which is bin bash, so like this shell environmental variable points to the program that represents the shell, which in this case is bin bash. This other environmental variable points to the current working directory, which is home SSH user. This is the log name, this is the home, this is have to do with the colors, we will see later. So all of these things are called environmental variables and they have the same syntax. The name of the variable equal the value of the variable. And they can be accessed with, for example, echo and then I say $ and I say shell. With this command, I have access to this environmental variable. So without printing them all, I can also print individual environmental variables. So for example, I can add the command echo here, where the command echo is simply used to print stuff. So the command echo prints stuff to the screen. It can be a literal string, like in this case, echo hello. It can be also an environmental variable. And to print out the value of environmental variable, I need to use the $sign. So I say dollar name of the variable, because in Bash, variables are prefixed by dollars when I need to use them. So when I need to refer to a variable, I say dollar. And here it stamps shell. I can also, for example, print the value of the environmental variable home, which tells me /home /SSH user, and so on and so forth. Now, the last thing is the following, the which command. And for me, this represents one of the basic information, because every time you use a program, for example, echo, right? The question is, but wait a second, where is this program found within the file system? Now, to actually map programs to file system, you can use the which command. How does it work? You write which and then the name of the program, for example, echo, and it tells you the path within a file system for that particular program. So this is the idea of which. For example, which env, it tells the path of the program that prints the environmental variables of the system. If I say which UMI, it prints the program that prints the current user, which ID, it prints the program that maps that prints out the current key, which hostname, every kind of program. Every time you, for example, write hostname, what actually happens is that this specific command, hostname, is actually resolved to its full path before being executed. So there is this translation process where you go from the command to the path of the command, and then you load into memory that binary, the program hostname, which is found in user bin hostname, and then you execute it. Which means that to understand which particular host name to execute, you need the full path, and you can see the full path of a program with the command which. Sometimes we have troubles using command line systems, command lines programs, because we don't even know which program we are actually executing. So in this sense, by using which, you can get an idea, okay, like this is the program that is being executed once I write hostname. Then you can go analyze that program, maybe see if it's well configured or not. So that's the idea. So this covers the basic information we can extract from the shell. To give a quick recap, and of course, by the way, you can find all these commands in my notes.txt. So here you can find all of these commands to play around with them. So the basic idea is that username, who am I, hostname, where am I, working directory, what is the current directory the shell is executing at, environmental variables, what are the variables of my environment, and the which command, which allows me to resolve the various programs. Now, I've already discussed in the path hijacking video, so in the path hijacking video that I've already done here, path hijacking, I've uploaded, it's called path hijacking, I've already discussed how this translation happens. So if you're interested in that, go and check out that video, but essentially, to give a quick recap, a specific environmental variable is used, which is called the path. So thanks to the path, the program which, and in general the shell, is able to resolve the programs to their full names, to their full path in the file system, and then it's able to execute them. So this covers the basic information. Now we can talk about relative and absolute path. Now, every time we have to specify the location of a resource in the operating system, as I said before, we need to specify its path. So the file system is sort of like this world, this map where we have different resources. And now when I want to access a specific resource, I need to say, okay, this is the path of the resource. Go and fetch it, go and use it. Now, having said that, there are actually two different ways of specifying these resources, and they are called respectively absolute path and relative path. So the idea is that the absolute path always starts with the root of the file system. So consider this path. It starts from /, then it goes to home, then to Leo, then to projects, then to foundation, then to YouTube-n, and so on and so forth. So the key idea to understand about absolute path is that they start from the root of the file system, which is the initial location, which is where everything starts off from. So the / is the start, then it goes into many different directories, and then you traverse the entire tree until you get to the actual resource. So this is one way of specifying a location. Another way is to use a relative path. Now, relative paths have a distinction in that they don't start from the slash, they don't start from the root, they don't start from the start. Rather, they start from the current working directory. So here we are already trying to link two pieces of information, right? So with this command, with the pwd command, we extract the current working directory. So notice here, so here with pwd we extract the current working directory, and then now I'm saying that relative path actually start off from the current working directory. So the idea essentially is that once you want to resolve a relative path, what you do is you take this path and then at the start, in the left here, so like here in the left, you actually put the current working directory. So you have to concatenate these two pieces of information, like so. For example, we have the current working directory and then I put the relative path. So to actually get an entire path, you have to take the relative one, but you have to append it to the current working directory. It's sort of like saying, instead of starting from the root of the tree and then going downwards, you start from a specific node, say for example this one, and then you go either up or down and so on and so forth. Now to specify the fact that you want to go one directory backwards, because the idea is that if you do not start from the start, right? If you start for example from this node, you might want to go backwards. You might want to say, look, I want to go backwards one directory and then forward another directory. So to specify the backward directory, the previous directory, you actually use this syntax, is dot slash. It's the forward slash. So you do forward slash, and this actually means go back one directory. If you put, for example, three times this forward slash, you are saying go back 3 directories and then move into the third OSCP, into the full directory and into the video directory. So this is the idea between absolute path and relative path, and it is highly connected with the working environment. And so this is a really important piece of information in order to read the path that you will use in the Linux shell. We will use this relative and absolute path. So now we have the file system commands. So as I said, one of the most important aspects of our operating system is the file system, because the file system is actually the place where our data is stored, which means that it is also the place where we can read our data. So every time we have to write a file, every time we have to read a file or create a directory, which is a container of files. So every time we have to interact with a resource in the operating system, we have to use the file system, because it is actually one of the most important things. Every program that exists, we actually write to the file system most of the time, most programs, if we want to use them many times. And then we read from them, we read from the file system, we put into memory, and then we start to execute it. So it's really like a crucial piece to understand well, because it's highly used. So how do we extract information from the file system? We start with the pwd command, which prints the working directory, because this is our entry point within the file system. So it tells us the location that we are at in the file system. So very, very simple. Now to actually change, so to move in this file system, we can change directories, because the idea is that, look, I actually want to change, I want to move between directories. So we can change directories, and another critical piece of information is to list out the resources in a particular directory. So for example, I can do cd and this is like, okay, go back one directory. I go back one directory, now I am in /home. Before I was in /home /ssh user, now I am just in /home. Perfect. I can go back another directory, so cd ... Now I am in the / directory, which is the root directory, which is where everything starts out from. So now I want to say, okay, I want to list out all the files in this specific directory, and I go ls. Now ls gives me all the resources in these directories where typically the resources are either files or directories. You have also different types of special files, but for now we just consider about files and directories. So here they are colored differently. So for example, these blue ones are directories, while this other color is like symlinks, so they are links to other directories, so we don't care about that for now. So like the idea is that, okay, I have all these directories. Now I want to change into a specific directory. What do? I do cd, which stands for change directory, and then I put the name of the directory I want to go to. For example, var. I want to go into the var directory, and I go cd var. And now I am in /var. If I print the current working directory, I'm no longer in /home. Now I'm in /var. I can go list out the directory in /var, and I can see, oh look, there is a backups directory. Let's go there. I do cd backups. I press OK, and now I do print working directory, and now I change directory. So you see, this is how we travel through the file system. Of course, if you are not used to that, it can be confusing, but the idea is that to develop this muscle in your brain to understand, okay, I am in this directory, I need to go into this other directory, I'm going to do a bunch of CDs and ls to move there. And notice that if we go back to the root directory, and we can do that with a cd /, it says go to the directory / go to the root directory. And we do an ls. Here we have a bunch of different directories. Now these are standard Linux directories, and you will need to understand the roles of each. I mean, you don't need to understand completely the roles of each, but for example, in /home, typically you will find the folders of the current user. So here we have two folders. We have the Ubuntu folder and we have the SSH user folder. So for privilege escalation, this directory is pretty important and you should know it very, very well. So this is the idea. We can go into the SSH user directory. So this is our home because we are the SSH user, and we go into the /home/SSH user and we can list out the files. So here notice I did ls and there are no files in this directory. However, actually, there are different types of files which are not shown here. And the ls command can be used with different flags. And once again, these flags change the behavior of the program. Now here, I'm not going into the details of the various flags for each program, otherwise this video would be endless. But the idea is that a useful command for ls is ls, then do -a. So with this ls-a, essentially, what I'm doing is that I'm actually printing all the files, even those that starts with a dot. Now, why initially they were not shown is because in Linux, there is this convention which says, look, if a file starts with a dot, do not show it immediately. It's called an hidden file. I mean, this is not really hidden, it's just for convenience. You typically use these files to configure your programs. So these are sort of like technical files you can think of. So the idea is, okay, we don't want the user to see all these technical files, so we want to hide them. And we only want to show them to technical experienced people that understand them, so understand their role. So this is why they're called hidden files. And with ls, you can extract them with -a. Another option for ls is -ah. Actually, I think it's -al. It gives you this kind of listing, which is more structured, and it gives you various information. And then if you want to actually get the size of in bytes of the various files, in terms of kilobytes, megabytes, gigabytes, and stuff like that, you can put the h option. So it's like you have different option. Here I'm just gonna save this as a proper option here. So into this list file because it's useful. And so to interact with the file system, so far we've seen working directory, change directory, and list files. Now, of course, we have three more commands, which is move files, copy files, and remove files. Now, these commands are pretty straightforward once you get used to the idea. So suppose that I have two files. So now I'm going to do an echo hello1, and I'm going to create a file test1.txt. So what I did here essentially, I'm not going to explain too much about it, but essentially the idea is that now echo typically prints out the content to the terminal, right? So if I just say echo, it just prints out to the terminal. With this particular command, what I said was that, look, you take the output that you were about to print into the terminal and you redirect it into the file test1.txt. So this essentially creates a test1.txt file, and I can look at the content with, for example, cat test1.txt. Now, cat initially was not actually developed for viewing files, it was developing for concatenating files. This is why it's called cat, concatenate, but you can also use it to view single files like that. It works okay, let's say. So notice that the content now is not printed on the terminal anymore, it's actually printed within the file. And with this we can create, for example, another file. So here I can create hello2 test2.txt. So now I have two files, cat1.txt and cat2.txt. And notice that if I use cat like this, so how am I using this program? I'm saying this is the name of the program and this is the argument of the program. So the argument modifies the way the program behaves. The argument is the name of the file test1.txt. If I put two arguments, it's actually gonna concatenate the results. So this is the idea why it's called cat technically. So we have these two files. So the idea is that we can move files. Now to move a file, what you do is you take move, you take the path to the file you want to move, and you define the new position of the file. So for example, a move command could be, okay, I want to rename test1 into test3.txt. I want to do just a simple rename. I press OK, and I've renamed it. Now test1 is no longer test1, it's rather test3. And so this is like a way of moving files. If I want to change the directory of the file, I can do, okay, test2.txt, I actually now want to put into /tmp. So I want to change the directory. So notice, here I'm putting the path to the file I want to change, and I'm putting the new path, the new directory. I'm not giving it the final name, and the move command is configured that when I do not give the final name, the destination name, it's actually going to keep the same name, it's just going to move its position. So I do this command, I do ls. Now notice here that test2 is gone, but now if I do ls/tmp/ I see a test2. And if I do cat/tmp/test2.txt, I see the content hello2. And if I do cat tmp test2.txt test3.txt, I see the concatenation where the hello2 is actually put first and the hello1 is put second. So this is like a lot of information I understand, but this is the idea. I'm just playing around with the shell. Notice also this, that here I put the full path to test2. This is like an absolute path, while here I'm putting a relative path. I'm not saying where it starts, because remember, it starts from the current working directory, which means that if I do print working directory, the actual path that will be used in the program is like this. So technically it's going to be like this. So this path is going to be resolved into what? Into, I'm going to take the print working directory path and I'm going to append it to the start. So this is actually the final program that is executed. This one. Because of course all the relative paths have to be resolved before executing. So I can either write like this or I can write like this, and the relative path is resolved to an absolute path. So this is when it comes to the move commands. Then we can do the same, but instead of moving the file, I'm just creating a copy. So it means that the destination will be created, but the source will not be lost. So that's the idea of the copy command with CP. So the idea is that I say, okay, I want to copy this time test3 into tmp, and I do ls/tmp. Notice I get test3.txt in ls/tmp, so I have created a copy there. But now if I do ls on the current directory, I still have it in the current directory. So the idea is that it exists on the current directory and also in the final destination. This was not true when I moved the file, because I say, okay, before moving, I do ls, and I have test2 and test3, right? Perfect. Then I move the file into tmp, and I do ls again to list out the files. Notice that test2 has disappeared because I moved the file. So moving means taking one resource from one place, putting it into another place. Copy, I still maintain the original. So when I copy, I maintain the original. And finally, there is rm, which stands for remove file. So this is the most dangerous commands, of course. So the idea is that suppose I want to remove this file. So I do remove, I do the path to the file. And that's it. I do ls, it's gone. It's no longer here. there are other files, of course, but there's no test tree. If I do ls/tmp, of course, notice that in this other folder, the file still exists because I just deleted the test3.txt that was in the current working directory. I did not delete it from the entire operating system. I just deleted from a single location. So these commands are extremely important to get used to it, and I just of course mention them. You have to do a lot of practice, but that's the idea. Like, this is a really key. These are all key commands that you must know about. So having finished the interaction within the file system, for basic interaction of course, these are just basic commands, other sets of commands which are extremely useful are those to interact with the resources of the operating system. So specifically, the file system is just one system, but the operating system has many different devices, has many different resources. Specifically, we have the disk, which is like the hard drive, the HDD, and we can sort of use it in terms of, we can understand how many devices are currently connected to our computer with the fdisk-l command. We can understand okay, but what kind of percentage of our disk did we use and what still is left. So for example, it could say, look, we have 30% of disk space left. So this is one resource, the disk. And then you have the processes. So the different processes is another resource that is handled by the operating system, but also you have the network interfaces. So you have network resources, which is another set of resources that is also handled by the operating system. So here I put the most important commands for all of this stuff. So for example, disk devices. Now here I have an output for the fdisk output. So consider sudo fdisk. So the idea is that this gives you the idea of the various partition in your hard drive. In your hard disk, you have different partition, and this gives you, okay, look, this is the start sector, this is the end sector, and this is the description of the partition, and this is the number of blocks, the size, and stuff like that. So this is technical information. It says that we have 31 gigabytes of disk, and this is not mine, it's just an example I took from the internet because I don't want to show mine. But the idea is that with this command you can extract information about your specific partitions in the hard drive. Then you have the disk usage. So for example, in terms of disk usage, you can either ask two different questions. So you can ask a question about the entire disk usage, so with this df-h. So the idea is that, for example, in this case, we have the various folders with the various file systems that are mounted on, and I've actually used 779. So I have 779 used, and available I have 92. So this is the root directory. Then I have others directories in which I have different sizes. So the idea is that it tells you for the different partitions, okay, these are mounted, this is the usage for in general for the entire system. So this is the df. Another useful commands is the du. The du instead is specific to a given folder. So essentially it says, look, in this folder I'm using 20 kilobytes starting from this folder. So as I said, imagine the file system as this root of stuff here. So the question is, okay, but starting from one specific node, so this node, what is the entire size of all this subtree, of all this section? And with the du command, you execute the du starting from a given working directory. So in this case, it's my home folder, right? And you get the entire size divided by folders, essentially. So this is the idea. For example, if I do in slash, I do du. Here, of course, it's extremely huge. I have 258 megabytes. It's actually not that much because it's just a Docker. And here I have divided by all the files with the relative size. So this is for a local viewpoint of the disk. Then we have the processes which are running. So let's say PS. So if I do PS and that's it, here I actually get the processes that are controlled by the current terminal. But if I want to see the system processes, I can actually say ps aux, and here it tells me, okay, look, I have, for example, SSHD because it's running an SSH login. And another question that I can ask is, for example, I want to see the hierarchy of the processes. So notice, I have the SSH server, which spawned an SSH session, which is the one I'm using, which spawned a bash interpreter, which spawned a bin bash, and now I'm spawning a PS. So like all these like processes are intertwined, and there is an hierarchy once again of processes. We have an hierarchy of file system, we have an hierarchy of processes. When you go inside a machine for like a privilege escalation, you need to understand what are the processes that are running on that machine. Because if you have a vulnerable server, if you have a vulnerable process that maybe you can only see from inside the machine, then you need to go with this PS, with this like command to list out all the processes that are actually running within the machine. So processes are one of the fundamental things you need to know if you want to do privilege escalation, and with these simple commands you can get a view of the processes that are controlled by the terminal, in general a list of system processes, and system processes with a given hierarchy. So this is useful commands. And then of course you have a lot of information for the different processes. For example, notice here it says TTY because for this bash session there is actually allocated a specific TTY. And remember what we said, that a TTY is a communication channel, and this communication channel is another resource that is handled by the operating system. So of course the operating system has all the information about it. Finally, another critical point that has to do with resource management has to do with network interfaces and in general with networking. So the idea is that modern computers have always network connectivity, like pretty much all the time. It is embedded into the kernel, into like the operating system software essentially. So every time we have a bunch of different network interfaces. And specifically when it comes to networking, the first question that we can ask is, what are all the different network interfaces that are available to us? And we can obtain this list with the command IP address. So notice here, currently I have essentially two interfaces. One which is the loopback localhost interface, which has this IP address 127.0.0.1, and another which is the ATH0, which is the interface that Docker uses to communicate with the Docker engine, because currently I'm inside a Docker container and it has to communicate with the Docker engine, because technically I can, for example, ping google.com. So this is sent, actually I don't have the ping command, but technically I do have internet connectivity. Let's see if I have the curl command. I don't have the curl command. If I have the wget, I have wget. For example, I can just get the main page for my website, and actually it says permission denied because I'm in the root. I go into my home folders and I get the index file. So notice here, this is the file of my home directory, which means that I do have internet connectivity. To obtain this internet connectivity, I actually have to use a network interface of the Docker engine. So here I have two different interfaces, and this is critical. Because once again, when we are doing a privilege escalation, sometimes we might get inside a host and discover that he has access to a specific network interface that was previously blocked, that previously we could not get access to. So enumerating the network interfaces available is fundamental. So this is like this other interface, and this is the 127.0.0.1, the localhost, and this is the internal Docker communication. And we can also write, like we can do it as IP address or IPA. So the IP command allows us to interact with the network stack of our system. And finally, another command that has to do with network is the one to enumerate the open ports. So we can do netstat LTPN, and here we get all the listening TCP ports that are currently running on our system. So it's sort of like we log in into a machine, we do this netstat command, and we get all the services that are running on that machine. And this can be really, really critical. Now, of course, for question of time, I cannot like zoom in into every option available for all of this program. For example, in this case, I say LTP because are the most important, options for specifically, but there are many other options. And when you interact with the program, you can typically say, look, netstat and then --help. So you can typically use the help command, and it lists out all the possibilities, all the options with the various usages. So for example, route or interfaces or groups or statistics. So to actually understand how to work with these programs, you need to sort of like understand how to read this syntax, how to read this documentation, which is really, really critical, because otherwise you might get lost into this like sea of commands. This is like a lot of different commands with a lot of usages. I just suggest to start slowly and slowly get used to like extracting all of these pieces of information. And so a quick recap: when it comes to resource management, we did the disk commands, the processes commands, and the network interfaces commands, so the network-based commands. So at this point we are almost over. We need to see 2 more sections. So this one has to do with users, and the final one has to do with packages. So when it comes to users, of course, as I said, the operating system has support for multiple users connecting and using the operating system at the same time. So we have a bunch of different commands that have to do with the management of those users. So for example, this user add command, which is typically called with the sudo. Now I will do a specific video on the sudo command, but essentially, to give a quick overview, the sudo command stands for super user do, and it is used when we want to execute an action as the administrator of that particular machine. So typically we are not always the administrator, that is, we are not always the root user, right? Typically we have our own user, and this is done for like security sake and stuff like that. But the idea is that when we actually want to execute a privilege action, when we want to execute an action that only the root user can do, such as adding a new user to the system, we can use this program, which is called sudo, that allows us to temporarily execute programs as root, even though we are not root. Like we become root for a specific amount of time for executing a specific commands, maybe with a password, maybe we have to authenticate ourselves with a password, stuff like that. So this first thing is like user add -m and then you put a username. So this is to create a new user. So for example, I am in my Docker here. Actually, I'm gonna put it here. I am in my Docker. I can do sudo user add /m leo. So I go into /home now, and notice I have also the leo user. So this is the first command. Now internally, how are user handled by the operating system? So there are 2 files of interest, which is the /etc/passwd file. So we go into the cat /etc/passwd. We cut out this file. Now this file contains a description like metadata for every user in our system. And specifically, there is the username, there is the password, the user ID, the home folder, and the shell to use for that particular user. Now here I said there is the password, but actually the password is no longer put into the passwd file. And if you notice here, we just see a bunch of X's, so there is no password here. The passwords for the virus user is actually stored in a different file called the shadow, so it is etc shadow. So the shadow files contains the passwords. So for example, in this case, here you can see the actual password, which is hashed. So this password is actually hashed, but you can find it there essentially. So you can do cat etc shadow. Of course, if I just do cat etc shadow, it's gonna say, look, permission denied, because you cannot see that clearly. But if I do sudo, I'm actually running a super user, so I'm actually able to actually see that password. So that's the idea. So this is to create a user. Now, if you want to change the password of a user, you can do sudo passwd. So I'm gonna do sudo passwd leo. I'm gonna put a password, I'm gonna put test. Now notice that when I did the cat etc shadow here to leo, it actually printed this exclamation mark. It did not actually print the hash of a password. This is because that particular user actually did not have yet set a password. So now if I see it again, if I do again sudo cat etc shadow, notice that now I see the hash of the leo password. So it has been set, and I can do su, which stands for like change user in a way, and then do leo. Here it asks me for the password. Here I can say test. So I type it wrong. I have to type it again. So test. And notice now that I am who am I? I am Leo. So who am I? I'm Leo. ID. I am Leo with the UID of 1001, with the GID of 1001, and stuff like that. I do exit, I go back to the previous shell. So notice that I can start one shell and then another shell and then another shell, and so my interaction with the computer changes. So going fast, this is how we create a user, this is how we change user password, this is how we delete a user. So sudo user del. So we do sudo user del, and then we can do -r to say delete also the home directory. So we say Leo, and then we say ls, and now we do not see anymore the home directory of Leo because we've removed it. And also if we cut the file tc passwd, there is no Leo here anymore. So here in this passwd, there is no Leo anymore. So this is how we delete a user. This is how we list the groups of a given user. So we have the id and we have my to get my information, but then if I want to list out the groups, I can either say groups. So this is my groups, and if I want to list out the groups of a specific user, for example of the root user, I can say groups and the username, and it's gonna give me the user of that user, the groups of that user. So because essentially groups are containers of users. So in a group you can have more users. For example, here I am in the sudo group and in the root group. So I can say groups, for example, let's say sudo. Actually, there's no such user, clearly. So let's say groups backup. The backup is in the backup group. www-data is in the www-data group. So not too much interesting, let's say. Then we can add a new group, and we can add a user to a group. So the group add is just say group add. You put the name of the group and you have created a new group. While if you want to add the user to an existing group, you just say usermod -a-g. You put the name of the group and then you put the username. So this, when it comes to user management, these are the most important commands. Once again, these are like the basic, I understand, but this is how you get started, by mastering these basic commands. If you master these basic commands, you at least know how to manage your system, and then you can go and explore more complex stuff. And then we go into the final section of package management. So this is the final section because essentially many times the programs that I mentioned before, like for example fdisk, right? Here I say, look, fdisk-l to get the information about the disk. Now, many times it can actually happen that you do not have that program installed in your system. That is, your system does not contain that binary, so you need to get it somehow. Now, the cool thing about Linux is that in Linux there are so-called package managers, which are programs that help you to obtain, to download, to compile, and to install other programs. So essentially, this is the idea of a package manager. So in this case, we are running Ubuntu. So we are running Ubuntu, and we can get this information by saying lsb_release-a, and here I get Ubuntu 24.04 LTS, so the long time support version. So this is like a useful command also if you're running Ubuntu, if you're running this kind of distribution. So many times we do not have the specific command. So how do we do then? We use a package manager. Now in Ubuntu there are two different types of package manager which are actually sort of like similar, and it's called apt and apt-get. So the idea is that apt is a simpler interface over apt-get. So we can say apt-help, essentially. It provides the same functionality as the specialized apt tools like apt-get and apt-cache, but enables options more suitable for interactive use by default. So this is the apt, and then you have the apt-get, which we can also use with the help, is a command line interface for retrieval of packages and information about them from authenticated sources, and for installation, upgrade, and removal of packages together with their dependencies. Now, the problem of managing dependencies is actually quite difficult. So here we talk about dependencies. So the idea is that every program can depend on other programs. So you create this network of programs and of like dependencies, this network of constraints, so that maybe you want to upgrade one program, right? But this other program does not want to get upgraded, and sort of like you break this kind of constraints, and so everything falls short. So these programs are like complex because they have to manage this kind of dependencies. However, as the final user, especially if you're a beginner, you don't really need to think about that. The idea is that you have a program to obtain other programs. And in this case, the program is called apt. So for example, you can say apt-get install fdisk, and it's going to install this program, fdisk. So I do this. Of course, it says permission denied, right? So I need to say sudo. And here it says okay, and then it installed it. And so like I can either do apt-get install or apt install with the sudo actually. Then I can search, because of course the problem is that how do I understand that the name of the package is actually called fdisk and not in any other way? This is actually tough. You can use search engines for this. They can help you, hopefully. So the idea is that all the commands that we've seen so far, these basic commands, are essentially the same over all distributions. However, when it comes to packages and how we manage them, this is highly dependent on your distribution. For example, for work, I use Ubuntu, while for my personal usage, I use Arch Linux, and they have two different ways of managing the packages. But all of the ways essentially allows you to install new packages, to search a database of information regarding packages, to remove a package when you don't want it anymore, to update and to upgrade. So there is a key distinction between updating and upgrading, because the idea is that to work, these packages, they have to download metadata into a local repository. So it's sort of like this is your PC, so this is your PC, and this is like a local repository of metadata. When you do update, you're actually not really like installing new version of the software. What is happening instead is that your PC communicates with the remote repo to sync up with the latest metadata. So it syncs up, it sort of says like, okay, of these packages, I have the latest version of these packages, new version have been released. So when you do an update, it's just like the exchanging of metadata. Then when you do the upgrade, actually you are downloading the new packages, you are installing them, and you are substituting, you are replacing the old packages with the new packages. So this is the key difference between updating and upgrading. Typically, of course, upgrading takes more time and you need to like update frequently to get the latest metadata. And then, as I said, you can search. For example, let's do this. So when you do search, it actually searches the local database for all the packages that contain that keyword. So in this case, it was disk. So look at this, small printer daemon intended for diskless workstation. So you get a description for the various programs. Here you have a bunch of libraries. So these are used when you want to develop something or you want to use a program that needs this particular library. So this is like, can be helpful. And so like you have a lot of different programs, and in this mess, there's also the fdisk, which is this one, collection of partitioning utilities. fdisk, noble, and the version. And it also says, look, this is actually installed. Pretty good. So this is how we search. To remove, we can actually do the purge command. So look at this, I go here, I say purge, with sudo of course. So here I just purge everything, I just delete everything, and now I do not have anymore the fdisk command. I do not have it anymore because I've deleted it. And finally, I can do the update to fetch the latest metadata. So here, I'm gonna get the latest metadata. Actually, I have to always do the sudo. So here it's downloading all the latest metadata, and I can do upgrade to actually swap the packets with the newest packets. So once again, I have to do sudo because I have to authenticate as administrator. So it says, for example, look, the following packages will be upgraded. So there are new versions for those packages. I say yes, download the new versions, and now I've downloaded the new versions. So essentially, this covers it, all the basic commands to get started with the Linux shell. To finish off the video, I will do a quick recap of what we treated so far. So we discussed the difference between the terminal, which is a graphical entity which lives in the GUI, the TTY, which is a communication channel, and the shell itself, which in this case is bash, but we also have another shell called sh. There's also fish, and so on and so forth. ZSH is even another shell. So it's ZSH is another shell. So we have different types of shell, different types of terminal, and typically the TTY is specific to the operating system, so that is kind of the same. Then we saw the commands to extract the basic information, because the idea is that when I use a command line, when I use a shell, I need to extract, I need to understand the basic commands that I need to extract the basic information. These basic information are: who am I, what is my user, what is the name I'm currently running on, the host name, what is the current working directory within the file system, and what are the environmental variables, and how can I print the single environmental variable with this syntax. Then the which command is useful when you want to extract the path that is actually like used to execute a program. Then we discuss about the difference between relative and absolute path. So there are two different ways of resolving path in the operating system, of specifying resources in the operating system. Then we talk about the basic file system commands. So to print the working directory, to change the directory, to list the files in the working directory, to move, copy, and remove the files. So this is like the basic interaction we have with the file system. This is really, really important. Then we have the resource management, which is divided into the disk, the processes, and the network interfaces and the network ports. Here I've shown an example with TCP. You can also enumerate the UDP ports. I mean, that goes like into detail, but this is the main idea. Then we have the commands to deal with the users. So remember that we have two specific and important files in Linux that manage the users, which is called the etc passwd, which contains all the username and the information about the shell being used by that user, and the shadow file in /etc/shadow, which actually contains the hash, the hash of the password of the user. So this is really important to manage the users. And finally, we discuss about package management. So the idea is that we use programs such as apt or apt-get to install, search, remove, update, and upgrade our system by interacting with a remote online repository that is contained by different programs. So we can download those programs, we can install those programs, and this is like done easily through this interface with apt. And all these commands with apt, they require the usage of sudo, because we actually have to be super users. Now, in this video, I mentioned a lot of things. I couldn't go into the details because it's really like a crazy amount of stuff to cover, but I hope that this introduction gave you some idea with respect to the Linux shell, how to orient yourself within the Linux shell. And as a final resource, I highly suggest playing with this website, which is called overthewire.org/wargames, because it contains a bunch of challenges essentially that you can use. So this is the site, and you can play with Bandit. So Bandit is the first. Now it contains many different levels. There are around like 30 levels that allow you to play with the shell, with the various stuff that you can do with the shell and stuff like that. So to actually get used to the Linux shell, you kind of need to do a lot of practice, and this overthewire.org contains a lot of levels that are really fun and useful to do when we are starting out learning the shell. So this is extremely useful, and I highly suggest this other than the usual ActiveBox, TryAcme, OSCP labs and stuff like that. So I hope the video was enjoyable. If you have any feedback, please leave it in the comments, and see you to the next video.